Thinking about events intimate to a replication fork, you might imagine a replication protein or enzyme complex moving towards the replication fork along the leading strand, and at the same time a second complex shuttling back and forth on the lagging strand in a kind of 2 steps forward, 1 step back replication dance to make Okazaki fragments. But we don't think this is what's going on. We say that replication is probably processive, a term intended to mean that the overall replication of both leading and lagging strands are nearly simultaneous. And this slide illustrates how we might imagine processive replication. First, after separation of parental strands of DNA, the lagging strand template is bent or looped over as shown here, allowing the assembly of a single replication complex or replisome. While steadily continuing to elongate the leading DNA strand, the replisome begins a new strand of primer using primase, which falls off the complex once the primer is done. The replisome then adds new deoxynucleotides to complete synthesis of an Okazaki fragment, even as it continues making more leading strand DNA. Next, there is a brief movement of the lagging strand template relative to the replisome as helicase, the red ring structure in the slide, unwinds more parental DNA. Primase reassociates with the complex, as several other proteins are thought to rearrange themselves to reform a replisome further along the unwound template DNA, again ready to start a new Okazaki fragment. Here it goes. The point here is that the new DNA strands, both the leading and lagging strand DNAs, are growing in the same direction.